Okay, I think we can get started. Gretchen's not in here yet. She'll wander in a minute, I suspect. Last week, at the end of class, we handed out a sheet of questions. I called them impossible questions, just meaning there's really no right or wrong answer. I thought I had additional copies of that, but I do not. If you weren't here last week, I can get you a copy of the sheet of questions next week.
Do you want me to go make a copy?
Oh, have you got? You haven't filled it out yet? Okay.
It's all filled out.
You got all my answers?
You got the right answers?
How many shall I make?
How many would like one?
Oh, I want one.
Okay, yeah, that'd be good. Thank you, I appreciate that.
Maybe 14.
No problem.
All right, here's the deal.
There we go.
Here's the deal with the sheet of impossible, or actually I called it unanswerable questions. Here's the deal with the unanswerable questions sheet. If you fill that out and bring it back to me, I will let you pick out one of my magazines.
Whoa.
I got a bunch of back issues of Creation magazine. Creation magazine, by the way, is kind of the precursor to Answers in Genesis. Originally, they were all from Australia, and then Ken Ham came to the United States, and disagreements happened. They actually split. They had a ministry split. Creation magazine is still around, and Answers in Genesis, of course, is still around as well. But they were selling these for cheap, so I got a bunch. So if you want one of these, I have 10 different magazines that you can pick from. If you would like one, all you have to do is answer some or all of the unanswerable questions on the sheet, okay? And get them back to me. You can actually give them to Gretchen by the end of the class. You get 2 weeks.
Hey, Corey's a harder grader than I am.
They will not be graded.
Are you gonna read our answers out loud in class? Oh, I'm not.
If you feel like you got the answer to an unanswerable question, you can share it if you like. But it really is just to get you thinking about different things related to the flood, and also hopefully to get you to get one of these so you can also read more about creation-related topics. Okay? Any questions on that? Melinda's making copies. Very nice of her. All right, so quick review from last week. We talked about geology was a primary focus. I completely ran out of time. Gretchen asked me this morning, you have less content today, right? And maybe I do, maybe I don't. I'm not really sure. Let's see.
You just have to tell him when the bells ring because he gets going and doesn't hear us.
It's hard to stop. You know, you're like running and someone says, stop! You can't just stop. Well, maybe you can.
a 15-minute warning then?
No, I can see a clock. It's just,
We don't care. He knows what time it is.
the problem really is it's not Bible hour, it's Bible 40 some odd minute, right? So it's hard. All right, so last week we looked at the first week, just to back up a little bit. My primary focus was interpretation. How do we read the Genesis account? Is it just some mythological story, or is it a factual historical account? What I was trying to communicate, and I tried again last week, but a lot of Christian academic scholarship tends to look at it through a cultural lens and not necessarily as real history. But if you just take the leap and view it as a real historical account and see what you can do with that, I would say you're better off. But also the New Testament authors, they tend to look back on the Genesis flood account and just accept it as history and not as a legendary account. So you have that too. I'm not going to force you guys to believe a certain way, whether it really happened the way it's written, or if it's an exaggerated local flood account. You can feel free to believe whatever you like. I argue for the global flood interpretation rather than a local flood interpretation. It's just where I'm coming from. So last week we looked at 3 lines of evidence that support the idea, support the interpretation of Genesis as a global flood event. They were ancient flood accounts all over the world. Ancient societies have had different flood accounts. It was suggested that maybe that's because there are a lot of survivors of the flood. We're going to look at that today and see if we can make any counters to that argument. But that would be an argument, by the way, if it's a local flood, just happened in the Middle Eastern region, there would be all sorts of survivors throughout the rest of the world, right? But perhaps there's ways to look at scientific evidence that suggests that that was not the case. So we looked at that. We looked at sedimentary rock layers that span whole continents. Thank you, Melinda. I appreciate it. Did everyone get one of these? Is that one? No.
Thank you.
Oh, I said, did you want one?
I said, did I have one? Not usually misunderstood, but yes.
That's great. That's great. Okay, last one. This will be a quick kind of recap of the last thing we looked at: lack of erosion and rock layers. I showed you this picture. This on the left here is a picture of two rock layers in the Grand Canyon. The red wall limestone on the top and the Muav limestone below it. You'll see throughout these rock layers just flat lines, right? There's just flat layer upon flat layer stacked on top of each other. On the right side, and by the way, secular geologists, we looked last week at the geologic column, which is the secular geologist interpretation of rock history, which stretches back 4.6 billion years, right? This is a time frame, I'll just say, a time frame that I would say is incompatible with a literal historical interpretation of Genesis. Genesis just doesn't have 4.6 billion years in it. It just doesn't. It's much less than that, in the range of thousands of years, right? But the secular geologic interpretation of all these flat rock layers is that they were laid down one at a time in inland seas, just through sedimentary deposition. So over millions of years, these rock layers were built up. The problem with that is, as it's getting built up, at any one point, there is a rock layer on the surface at the top. Anything that is on the top, that's a surface level rock layer, is subject to weathering and erosion. Weathering is the process that breaks up the rocks. It's wind, rain, dust storms, whatever. It's what's eating away at the rock layer and breaking it into smaller pieces. Erosion is the process where water comes in and transports away all the broken pieces. Okay, makes sense? So any rock layer at the surface is going to be subjected to wind, rain, all those forces, get broken up, and gradually get eroded down to an uneven surface. Wow, that doesn't show up at all, does it? We can see it, that faint green line there, uneven surface.
Yeah.
So here's an example of an erosional surface layer. Death Valley National Park, California, the Devil's Golf Course. Has anyone heard of this? Has anyone seen this in Death Valley? Doesn't seem like a real friendly place to go. I think it's an apt name, though, the Devil's Golf Course. Can you imagine? The person's in there for scale, but just, it's a flat rock salt plains. It's a big flat open area, but it's been so eroded into just this uneven surface. This is what we would expect had these layers been laid down over millions of years. Each surface should be uneven like that and just stacked on top of each other. Here's another part of Death Valley National Park. These are just rock outcrops that have been eroded away mainly by the action of water. So you can just see this is what we'd expect. Any surface layers would be irregular because the water would be chipping away at it. And then this is also something I showed last week. Gretchen and I went to, say it for me, Cuyahoga.
Okay.
Cuyahoga. I always want to say Cuyahoga.
Look at it.
Cuyahoga National Park in Ohio. This is the Brandywine Falls. If you just look at it, this is a picture I took of it. If you just look at it, it's a bunch of flat layers on top of each other, right? Same thing you'll see all over the country. You'll have the National Park sign, and I'm pretty sure you can't read this, but it says 350 million years, 340 million years. So it's saying that all these layers were laid down over millions of years. So just something to keep in your mind as you're doing your travels throughout the country and you come across these geologic formations, when it tells you millions of years and all you are seeing is flat rock layers, the question to ask is where's the erosion? Where the signs of erosion should be there. Yeah.
What I don't know if I said this last week, I don't think I did, but when we were in Israel, it was really cool to, as we were going down to the Dead Sea, we stopped, and it was cool hearing it from a guide, a Christian guide, about the layers, because there were flint layers.
Oh, okay.
And then he explained how they used the flint, obviously for fires and stuff like that. And so to have it from a Christian perspective, where the world's not a million years old, and he's explaining, you know, that was really cool for us to see and to hear, and you know, just being there.
So they had exposed layers, you could see them.
Yeah.
That's all.
Yeah, I forget the valley that we were in. It was very, very cool. It's kind of like those rocks in Arizona that you see that people go and visit with the crevices. But yet you could see all the layers because we were very low. Sea level.
Yeah, you know, Israel, other side of the world, same thing there. You see all these rock layers that could only have been laid down through a massive flood, right? Because that's how the rock layers like that are formed. So yeah, it's just confirmation everywhere you look, if you have that mindset. But you see what you want to see sometimes, right? If you're convinced that the Earth is 4.6 billion years old, you're not necessarily going to see a rapid deposition in the recent past. It's just not how you look at it. So here's a comment that a secular geologist made in looking at a different rock formation similar to Grand Canyon. He said the regularity and parallelism of the layers in well-exposed sections suggests that all these rocks were deposited in a single uninterrupted sequence. In other words, not over lots of time. They're just one right after another, probably a matter of days or weeks or months, not millions of years. So this is, you know, something a secular geologist sees. It's what's apparent in the rock record. Okay, so here's the last word on erosion that I'll just bring to your attention. This doesn't really suggest anything definite, but it does kind of put time limits on things. There's a study that was done on the erosional rates of a very particular type of rock, and you looked at two things, outcrops and basins. For the outcrops, the average erosion rate was 40 feet for every 1 million years, if you extrapolated it. The continental crust is at most about 2,000 feet thick. So that would suggest that after 50 million years, the continents would be eroded down to sea level. And for the basins, it's even faster. The erosion rate would suggest that the continents would be eroded down to sea level in less than 3 million years. So this is another thing that's incompatible with a billion-year history of the continents. And by the way, in secular geology, the supercontinent was believed to have been around about 1 billion years ago, and then it split. So the only thing that's really been active since then are plate tectonics, which the idea is you'll have one continental plate going up on another, and that pushes up mountain ranges. But that happens very, very slowly. And when you compare these rates of erosion with the movement of plates, erosion is by far the dominant process. So I don't know if this is making sense. The idea here is that erosion happens at such a rate that if the continents were more or less in their present form 50 million years ago, just what we've observed happening in the present day, everything should be at sea level. Because that's the direction water wants to go. It wants to take things downhill on its way to sea level.
Does that simultaneously argue that the planets weren't all connected at one time then?
Say that again?
Does that also suggest that the continents weren't connected at one time then?
I wouldn't say that necessarily does. It's mostly just a comment on how quickly erosion actually works on rock features and reduces it down to nothing. I had to put on the cutting room floor the supercontinent argument.
We had a nice dinner discussion on this the other night. I was looking forward to it.
I was only given a certain number of weeks.
No worries.
So, unfortunately, I can't cover everything. I have one of my books on flood geology is 1,400 pages, by the way. Big doorstopper of a book. To cover that, I think, in a class like this would take years and years. It's something you have to devote yourself to studying, honestly. I can only give you some certain highlights and then give you magazines, and hopefully you take it up from there.
Can I ask a question?
Yeah.
Do secular geologists think the Earth is billions of years old?
Oh yeah, for sure.
How do they look at what they see and what one of them said, like this happened really fast, and combine those things?
Well, that's a bit of a can of worms. The
Okay.
4.6 billion years, I'll just say the 4.6 billion years, that is a radiometric measurement. What they did was they tried to find what they consider a basement rock level, a rock level that was there pretty much from the beginning. And then they do radioactive isotope ratio comparisons to see how much of decay has happened. And that's when you run into big questions about radioactivity and whether or not it's a well-known, well-studied physical process, but the question is the rate truly a constant, and can it be used as a clock to date things? And the short answer is no, it should not be used as a clock. It is an erroneous application of radioactivity to use it to date anything. But that would take a little while to explain as well. But that is why that's where the 4.6 billion year figure came from. There's really no other reason to believe it's that old. By the way, as an aside, people have been to Epcot and Disney World. They have one of the films that they show there. It's called Awesome Planet, and they run you through this geologic history. It's a beautiful, gorgeous film. It's only like 15 minutes or so, but they show a primordial Earth. They show an impact of a Mars-sized planet slamming into the Earth, and then kind of a big explosion, and from that the moon is formed. Like the whole secular geologic history of the Earth kind of laid out and argued for by this film. And then it kind of turned from there into ecological, social issues. But it was just really interesting to see that, such a stark visualization of that perspective. But it very much definitely goes back billions of years. This is something very recent. This is based on a study that was published earlier this year in May. It kind of relates to Dave. I feel like it was you that asked last week where the water came from. Is that similar? This is a team from the University of Alabama. What they were doing, and this is a picture from their paper. What they were doing from Antarctica, they were measuring reflected seismic waves off of the core mantle boundary inside the Earth. So there'd be a seismic event at or near the surface that would send pressure waves going through the Earth, and then that would bounce off the core mantle boundary layer, and then they'd measure it back at home base. You can kind of see it in Antarctica. And they were using this to map this boundary layer deep within the Earth. This is like 4,000 miles underground. It's really fascinating how they did this, and super complicated. Anyway, they wrote a paper. This is what they called their paper: globally distributed subducted materials along the Earth's core mantle boundary, implications for ultra-low velocity zones. That might not make any sense. Well, I'll show you a picture. It might make more sense when I show you the picture. But they wrote that paper, and then same people wrote this that's published on the University of Alabama's website: beneath the Earth, ancient ocean floor likely surrounds the core. So and I find this interesting, you see this all the time, in their paper, which is published in a geological journal, they've got their interpretation of what they saw. In their popular level article that's on the university website, they're just saying what it looks like. And what it looks like is an ancient ocean, deep, deep underground. But it's a different interpretation. So there's either an ancient underground ocean that was right above the core of the earth, or the rock layers, and kind of see it here, but the idea is that ocean crust made it down near the earth's core, and then it kind of solidified on the bottom. It moves around and then gets pushed back up. It's kind of a cycle. Rock goes down, hits that boundary layer, starts looking like ocean crust down there, and then some of it gets pushed back up. But let me go. But the red part there is what it actually visualizes as their measurements. So what it looks like is the bottom of the ocean. Now, this really doesn't prove anything, but what it suggests is that there was water deep within the earth. Most of it, probably almost none of it, is still there. But it would form, this water formed these distinctive features on top of the core that looks just like the bottom of the ocean. So this is possibly an answer to the question, where did the water come from? But what can't be known is how much water was down there originally, so how much water was released to the surface when the fountains of the deep cracked open. And this would have been high pressure, high temperature water, which came up from deep below the earth and up into the atmosphere, probably in huge jets. But there's no way to know how much water could have come from there. But another way to look at it is how much more land was on the surface compared to now. And we can get an idea by looking at how much fossil fuel deposits there are on the earth. So here's the current surface land cover breakdown. Most of it, 70%, basically is ocean water, salt water. A little bit of freshwater lakes, farmable area, less than 9% mountains, snow-covered dry land, and then no topsoil. So at most, it's 30% potentially that you could have plant life. And fossil fuels, maybe you don't know, maybe it's common knowledge, I don't know, but fossil fuels, that's just compressed plant matter that's been converted into a different form of hydrocarbons like coal, natural gas, oil. It's predominantly plant material that's just been smashed.
So not dinosaurs, but plants.
There are some, there could be biological animal remains that were compressed, but the vast majority is just plants that have been compressed. So at most, the present day, this is the top line here. At most, present day amount of plant life could account for 3% of the Earth's coal reserves at most. So part of the secular interpretation here is that coal has been forming almost continuously over the I shouldn't say 4 billion. It's just however long plants have been around. There have been events that have produced coal deposits. So over the long history of the earth, that's how you'd end up with all this coal that we find. However, the lower sequence suggests that instead of 30% of the Earth's surface being capable of supporting plant life, you'd have much greater land surface. So this model suggests 50%, so another 20% of the Earth's surface could have been land. And in addition to that, they're also suggesting there were massive, honestly, I don't know what evidence there is for this, but massive floating forests. So just on the water to have floating forests. But the long and short of it is, based on how much fossil fuel deposits that have been located, if we assume that they were all formed in a singular event, like a global flood, numerically, it's 6 to 13 times the amount of plant material than exists on the surface of the earth today. So a minimum that suggests any land that was on the surface was very lush. So no deserts, probably no ice-covered continents like Antarctica, but very, very green world, except for the ocean parts of it. But the flood model makes much better sense of the fossil fuel deposits that are found today compared to the slow and gradual possibility. So in other words, the water that came up from the deep ocean, the deep underground ocean, it wouldn't have to be all of the ocean water, but it could be in the neighborhood of 20 to 30% of what is currently on the surface. Could have been what was buried underground as part of the deep ocean. Okay, so the last comment on fossil fuels is that without fossil fuels, our society could not exist, would be the argument. I don't know if that's just something that makes intuitive sense, but here's an article in Time magazine. They focused on 4 specific things that are all very much dependent on fossil fuels to form them. Cement, steel, and plastics are the first 3, and then the last one is synthetic ammonia, which is produced from natural gas. Without synthetic ammonia to be available as a fertilizer, 8 billion people on the earth would not be supportable, wouldn't be able to feed that many people. The population would have to be roughly half in order to have enough food to feed the population if we did not have synthetic fertilizers. And without fossil fuels, it just wouldn't be an option. So the suggestion I'm advancing here is that God was sovereign over humanity prior to the flood. He exercised his sovereignty in the judgment of humanity by killing everybody except for the people that were on the ark. But through that process of the global flood, he also he set the stage for our society to be able to exist. Because without the flood, all the plant material that was on the surface of the earth at the time before the flood would not have been covered and would not have been converted into fossil fuels. You follow? So what I'm suggesting here is that God set the stage for present history. And this is something I hope to build on in the last couple of weeks, that we're at one of those very interesting focal points of world history that really points back to the biblical narrative in very unique and interesting ways. So here's a map of the world population growth over the last few thousand years. You can see right up until 1500 is basically pretty much flat. You do see a 7-fold change in 2400 years, but right around 1500, when technology starts to get developed, particularly 1800s, 1900s, when fossil fuels are starting to get exploited as a usable energy source, you see the population explode. And this goes back to, we looked at this last week, 2 of the core commands of God to humanity: be fruitful and multiply. So again, without God having set this stage for a population explosion that could only happen in the present day, it would just be continuing along that trajectory, just a flat trajectory, right? Okay, so the next thing I want to discuss is the biological connection to the flood. Now, we don't have time to go into this, but one of the strengths of certain flood models are how they can explain an ice age. And probably the key to this would be going back to the fountains of the deep. If a significant amount of superheated water came up from deep within the earth and came up to the surface, it would have significantly warmed the oceans. Warm oceans means you have more evaporation, you have more precipitation, you have more cloud cover. temperature drops, and you just start getting this cycle, a lot of rain, a lot of snow, temperatures dropping, but still warm oceans. And depending on how hot the oceans were, the cycle could continue on for hundreds of years, and the end result would be a sustained ice age, where you have glaciers that go further and further down from the north. The other thing that happened as part of the ice age is that a lot of water was drawn up into these ice layers, and so you'd have all these land bridges because the overall ocean levels would be reduced, so you'd have lands being connected to each other that would not normally be. And so this is one conception of how people could have spread throughout the world utilizing these land bridges. Now, I hope this isn't too technical, but I find this very, very interesting, this last part of the class today I want to talk about. This is based on research by Nathaniel Jensen, who's actually a guy that myself and a group from church got to meet when we took a trip to the Creation Museum a couple of years ago. We got to meet with a couple of the staff scientists at Answers in Genesis, and he's one of the guys that we got to meet. Super nerdy guy, to be honest with you. But very, very sharp. Very, very sharp guy. He's written 2 books. At the time, he had just written the first one, Replacing Darwin. Last year, he published Traced. The first one, Replacing Darwin, looks at the genetic chronology of different animal species, and Traced, he looks at human genetic populations. These books are interesting in that they are somewhat technical, but you really get into his thought processes, and this is somewhat unique, at least in amongst books I've read on scientific topics. You don't always get a full-blown explanation of the author's thought process as they're building their argument. But in Traced, he uses Y chromosome haplogroup tracing. Everyone knows about Y chromosomes, right? No? Yes, maybe. Those are chromosomes only males have. So this Y chromosomes will trace the paternal lines. So it's from father to son. Women, you can't actually trace your ancestry this way. And by the way, has anyone done any of those genetic tests where it tells you where your genes are? I know Gretchen thinks they're terrible.
Don't have anybody in your family murder anyone or you'll get caught that way. You don't own your DNA anymore.
Yeah, they actually have been used to solve a number of cold cases. I guess the federal agencies can get access to these things and find people with similar DNA and then start investigating various branches of that.
So they found a guy down in Florida.
Yeah.
Killed quite a few women.
Well, I mean, whatever it takes to get serial killers, I don't think I'm opposed to that.
We did some genetic testing we did one of those kit things for Mallory to see what she's got in her. So we have no idea with her being adopted. So
yeah,
quite interesting.
With men, you can trace genetic ancestry because you get the whole half of the DNA. With women, because you have just 2 X's. And it could come from, you could be looking at you don't know if you're looking at, is this the father, is this the mother, because they're both X's. So what they'll try to do is the mitochondrial DNA, the mtDNA, but that's part of the genetic code that really no one cares about. It's just the mitochondria, it's just a cellular energy factor. It doesn't encode, it's not genes that encode any physical appearance or anything distinctive on that end. Anyway, Jensen in his book, he looks at the Y chromosome haplogroup in particular, and a couple things just to maybe get us closer to the same page. So genes in general are just a long sequence of nucleotides, and there can be up to 10,000 or more of them. And they make up the chromosomes. The Y chromosome, father, son, this term haplogroup That's just the language, the vocabulary that's used to refer to genetic populations based on shared gene variants, okay? And it starts with A, goes down to, I think, N, like capital A, and then there'll be a lowercase a, and then a number, and then another letter. So it starts out a big letter, and then it breaks it down the further you are from the original A. And that may not make any sense, but you got to read the book, it'll make more sense. But, on average, and you can kind of get an idea of the chronology based on the rate of mutation. And there's been several studies on this, and the average rate is 3 copying mistakes per generation. So you're gonna, I would be, on my genes, on average of 3 nucleotides different from my father, and then 6 from my grandpa, and so on. So you can kind of get an idea of how many generations are involved in an ancestry as you look at the genes. There's a couple of pretty big databases of these genetic sequences that can be referred to. And what he did, here's one example. He's got 2 haplogroup genetic populations, and he compares their prevalence, in this case over Africa, parts of Asia, and parts of Europe. So he's comparing the 2 of them, and in these different spots, the size of the circle represents how prevalent that particular gene variant is in that population. And so from this, you can infer how different population groups are moving through space and time. And it takes a lot of logic. You have to know a lot of history. You got to take a close look at the genetics, obviously, but you can kind of track different people groups through history using the genes. And so here's what he does with it. This is a breakdown of all the major haplogroups. If you zoom in on this, you see a lot of more minute details. But what becomes apparent when you're looking through these genetic databases is that it breaks down into 3 main branches. And it doesn't show on these, but the time frame, so on the right we've got present day. If you go back to when these 3 branches split off from the common ancestor, based on this mutation rate, 3 per generation, puts it at about 2400 BC to 2000 BC. In other words, 4400 to 4000 years ago was when these 3 branches split off of the parent. That chart on the right there, with all the letters on there, that is all the people groups on the earth. Everybody's included.
So that is after Noah, his 3 sons? Is that what you're saying?
This is just what the genetic data says. If we're going to assume it's Noah, next slide here, what can we do with that? Genesis 6 talks about Noah and his 3 sons, right? Genesis 10, it starts to break down subsequent generations after the 3 sons, and it even names a few of them, right? Like we can, for example, Shem, we can track further down, and he's the one that is the ancestors to the Jewish people. Japheth is the Greeks. Ham is Egyptians and some of the African groups. So that's what we get out of Genesis 10. If we go back to the genetic data, that's exactly what we see reflected. And these 3 branches are who we would expect to see, these different people groups, if Genesis 10 were actually true, right? So, I mean, it's not that big of a leap, right? The other thing to point out here, well, the chronology, he does have a caveat in his book, is that what he doesn't know is that Noah was 500 years old when the Bible says he's 500 years old when he started to have his sons. What is not known, and it can never be known, honestly, is how age affects the number of copying mistakes that you pass on to your progeny. Because he was 500 years old, it might have been more, but he was also closer to Adam, which we would assume to be genetically better than now, as reflected in their longer lifespans, perhaps. So he might have also had less. So the exact chronology is not something that can really be nailed down, but it certainly gets close. If you remember last week, we looked at the basic biblical timeline would be 4,900 years ago for the flood. So at 4,400 years ago, based on this genetic analysis, I mean, it's right there. But this also kind of answers the question, could there have been survivors of the flood? Well, this represents all people groups on the earth today. And no one's excluded from, there's like no subpopulation of humanity that isn't in one of these three branches. So that definitely suggests that there was a singular origin point for all of the peoples on the earth today, and it was about 4,000 years ago, give or take, when it branched off.
The first off was what? Oh, was it the second?
Might have been.
So what can we conclude from this? Well, if what God wanted was a human population that spread out over the earth, he certainly set the stage for it. He gave us the natural resources that we would need in order to be able to do that. He also set the stage for diversification of human populations. However, he rearranged things geographically during the flood. That's another discussion. But genetically, as people spread, they would tend to become adapted to their environment, and this gets into the whole natural selection and population health part of the genetics. But they would diversify. They would have different characteristics that would help them thrive in the environment that they found themselves in. And this kind of points to the scene in Revelation where it says, "After this I looked, and there before me was a great multitude that no one could count, from every nation, tribe, people, and language, standing before the throne and before the Lamb." So this is at the end of history, right? Mm-hmm. At the beginning, it started out with just one person. At the end, it looks forward to a time where diverse peoples from all over the earth, different cultures, different appearances, different capabilities, would gather together and worship Jesus. And that definitely seems to be one of the things God was looking for in this creation project, was to get that diversity. So, yeah.
Are assumptions made that the wives of Noah's sons were from different origins or areas that affected the later generations? I know you go back with the Y chromosome back to the males, but we're still talking about two people. Mm-hmm. And if they were all from the same region or from the same tribe, so to speak, it wouldn't have the diversity. It would seem.
It wouldn't have the extent, but this is not affected at all by the genetics of the wives. And this is just strictly what's passed down father to son. So the genetic makeup of the wives of Noah's sons, no impact whatsoever on this. But yes, I mean, it definitely could be a factor on the X chromosome side.
Or how we get color, how we get shape, how we get whatever.
Yeah,
I mean, it
yeah.
had to come from other than that.
Right,
it seems it would have to come from other than the sun.
But it's the coming together of both the X and the Y that produce
right.
all the physical characteristics of an individual. So this is kind of at the forefront. Nobody else is really looking at genetics in this way, and it's still somewhat in its infancy, I would say. He does make the comment in his book that at this point, millions of people have had genetic testing done, but only a very small portion of that is of a caliber high enough to be used for genetic population mapping. But the more people that actually send in their DNA to be tested and provide a concrete genealogy to go with it, the more some of the blank places in the mapping can be filled in. But what he does have is enough to categorize all the major population groups: South America, Africa, North America, indigenous and immigrant populations. It really covers, I think you said 97% or so. So I, if you're at all inclined or have any interest, I definitely would recommend at least Trace. Replacing Darwin's a little bit tougher of a read. All right, so I will stop there. I think I went over time again, but remember to answer your unanswerable questions, and you can trade it in for minutes. Well, thanks, everybody.